Welcome. Today we're going to talk about the law of cosines and how you can use it to help find parts of a triangle, and it does not have to be a right triangle as you can see from the diagram. If triangle ABC has sides of length A, B, and C, lowercase letters, notice, as shown, then the following equations could be used. A squared equals b squared plus c squared minus 2bc cosine of A. Now, all of these are very straightforward and fairly easy to do. Whenever you're working with this, you don't have to have these exact letters in here. If you're trying to find angle A or side A, let's say that's the one you're trying to find, then you're going to use this first equation, but as I said, it doesn't really matter which side or angles you're working with. If you're working with these two, let's call it A and side A, then you're going to have angle A for the cosine part, and on the other side of the equal sign will be side A squared. The other two sides, doesn't matter which one comes first, get squared added together, minus 2 times the other two sides cosine of A. And that's the process. Once you get used to it, it's fairly straightforward. Now, when you're trying to decide which thing to use, which of these methods, law of sines and law of cosines, it will be helpful to know what you're starting with. If you're starting with 2 angles and 1 side, or 2 sides and the angle opposite one of them, so 2 angles, any one side, or 2 sides and the angle across from one of the 2 sides given, then you can use law of sines. If you're given 3 sides only, no angles, got to use the law of cosines. 2 sides and the angle between them, that's what it means by included angle. So side 1, side 2, and the angle here in between them. Then you're talking about law of cosines. All right, so let's put that into practice. Here's our first example, and in this example, I have not labeled any of these, notice that. The angle and the side across from it are our 2 things that are going to be at the far ends of our equation. I've got x squared equals, so that's the side across from the angle, the other 2 sides squared added together, so 13 squared plus 15 squared. Minus the other 2 sides times 2, cosine times cosine of the angle, of this angle, sorry, I was pointing the wrong place, cosine of 25 degrees. That's a 5 there. There we go. Now it looks funky with the 2. There we go. Cosine 25 degrees. All right. So the first thing I need to do, several first things I'm going to do, I'm going to go ahead and do the squaring and the multiplying where I can. So 13 squared, 169. 15 squared, 225. 2 times 13 times 15, negative 390, so minus 390. And then I can take the cosine of 25 degrees. Now, whenever we take the trig function of a degree, we are going to round it to 4 decimal places. So 0.9063. Next thing I'm going to do is I'm going to do this multiplication, and I'm going to do, this multiplication, this addition. That's what I meant to say. So x squared equals, let's see, 394 minus 353 457. Okay, so the next thing I'm going to do is I'm going to combine these together. That gives me 40.543. Then I have to finish it up by square rooting both sides. And as you saw up above, we're going to round our final answers to the nearest tenth, or 1 decimal place. So when I do this, it comes out to 6.4 when I round it. And that's the process of using law of cosines. Now, I'm going to do the same law of cosines, but this time I have 3 sides and no angles, and I'm trying to find a particular angle. Now, in this particular case, the angle I'm looking for is this one right here. So the side across from it is what's on the other side of the equal sign. So 22 squared equals the other 2 sides, 25 squared plus 28 squared. Now, for me, personally, I like to do whatever numbers on this side, the other 2, I like to put them in numeric order, but it's not necessary, but it just helps me keep track of what I've done. Minus 2 times 25 times 28 cosine of x. Probably should have left room there. All right. Now that I've done that, I got some simplifications that I can do. I'm going to do the squaring here, 484. Square here, 625. Square there, 784. I'm going to do these multiplications, that's 1400. Cosine, oops, x. All right. Now, here's where a lot of students make a mistake. They try to combine these 2 and this, but that's multiplied times cosine of x. You can't do that. So make sure you're paying attention to that. Now, when I combine those 2, I get 1409. Minus 1400 cosine of x. I'll now have to bring the 1409 over. And that leaves me with negative 925. Doesn't seem right. Let me just double check something. Yep, nope, that's correct. Anytime your intuition tells you something's not quite right, double check it. It never hurts to do that. Just costs you a few seconds. All right, we're going to divide by negative 1400 so that I can get cosine of x by itself. That leaves me with, now I'm going to use the full display here. I could round it, but I think we're better off using the full display since you're going to have it in your calculator anyway. 0.6607, 14285. Here's where we're going to use our calculator. And we're definitely going to want to do the inverse cosine here to find the value of x. And that's going to give us 48.6 degrees. And there you have it. So that's using law of sines and law of cosine, excuse me. to find our final answer. Where did that come from? All right. Now, that's great, and hopefully you followed all that. But now, I'm going to, from scratch, do this problem. I haven't done it ahead of time. I need to draw this out, so I need a sketch of this. All right, 110 degrees is more than 90 degrees, so it's an obtuse angle. Now remember, you're drawing a sketch here, so don't expect your sketch to be perfect. Also, remember, a lot of times when you're doing your sketch, you may be putting in an angle that's an acute angle instead of an obtuse angle like this. And watch out for the fact that sine can have an angle here and an angle here, and those two values, when you do inverse sine, it'll only give you this one, it won't give you this one, so you have to be very careful of the results of law of sines. You can always test it with law of cosine to be certain it works. Anyway, let's continue. Also, it's a sketch of a triangle, so your angles aren't necessarily accurate. This looks like it's a scalene triangle where all the sides are different. Maybe two of the sides are the same. Who knows? We won't know until we actually find more information. So I'm going to say this is 110. There's my angle A. My sides, now this would be side A according to that. So my sides B and C, it doesn't matter which one I put where. I'm just going to put B here and C here. It turned out, coincidentally, that that does match the lengths that I have up there. But that was just a coincidence. So I don't really need the labels, as we saw before, to write out my equation. Side A squared. Now I'm going to take my two B and C, coincidentally, 12 squared plus 15 squared minus 2 times 12 times 15 cosine of angle A, which is 110. Now, again, remember, the formula, the side across that you're trying to find across from the angle that you have, or the angle that you are trying to find across from the side you have, they're on the far ends. The other two sides, added squared, minus 2 times those squared. The other thing people forget a lot is the 2. They forget to say minus 2 times. They just do BC, cosine of A. All right, so let's do this out. 144, 225, and let's see, 30 times 12 minus 360. Now, cosine of 110. Cosine here in the second quadrant is negative, so I get a negative 0.3420. All right, let's continue. I'm going to do this addition and this multiplication. 144 plus 225, 369, plus, because negative times negative is positive, 360 times 0.3420 gives me 123.12. So now I'm going to add those two together, plus 369. A squared equals 492.12. Now I have to square root both sides to solve. A equals 22.2. We're rounding to just one place. All right, now I have A, 22.2. A, 22.2. All right, because that wasn't there before, I wanted to put it in a different color. All right. I have a side across from an angle and the other two sides. Now I can choose now to use this side and find another angle using law of sines, or I can use law of cosines. Now you can choose which method you'd like. I'm going to use law of sines because it's a little bit shorter, but you certainly can use law of cosines. In fact, if this were an acute angle, I would probably use law of cosines to find the next angle, just to be on the safe side because of that two possible angles, and it only gives you the smaller one with law of sines. So let's do that. Nope, that's not what I want. So we're going to use law of sines. So sine of 110 over 22.2 equals sine of over, let's do 12 and the angle across from that here. Let's call that B, because that is across from side B, angle B. And 110 sine is 0.9397 when I round it. Now remember, 180 minus 110 would be 70, and if we did sine of 70, we get the same value, and that's what I was talking about before. All right, so let's cross multiply and solve this. When I multiply diagonally here, I get 22.2 sine of B. And on the other side, 12 times 0.9397. 11.2764. Divide both sides by 22.2. Sine of angle B. 0.5079. So once I do that, I then would have to do the inverse sine. And let's see. Once I do that, I have the inverse sine to do. I could do the inverse sine of the full display, or I could do 0.5079 inverse sine, and it gives me almost the same thing. Angle B is 30.5 degrees. So that really doesn't make a whole lot of difference. Now let's go back up to the top and fill that in. 30.5 degrees. I have two angles in my triangle. Well, it simply is able to be found for the third one, 180 minus 110 plus 30.5. And that's going to be angle C, the measure of angle C. 180 minus 110 equals minus 30.5. That's 39.5. And there you have the full triangle fleshed out. Now we could have done that if we had a different setup to start, but that's how it works. And that is all we have for today. Thank you very much.